Now let's do an exercise where we have multiple files open at the same time. In this program, we are going to open up a file and we're going to read in the contents of the file. We'll make some changes and then we're going to write out a new file that has those changes in it. And for this example, I'm using a file called sampledna.txt. So let's just take a look at what that file contains. This is just a file of generic DNA, and doesn't represent anything in particular. It's just a bunch of bases. But you see it's a pretty big file, and in fact, I made this file with 1,000 bases there. Notice that we have several lines in the file, so even though you can't see it, at the end of each one of these lines, I have hit the enter key, so that has generated a line feed which sends us back to the new line over here. So the length of the line is all the characters you can see, plus we have the end of line character in here. But you'll need this file in order to do this program. Now, the first thing we need to do is we need to open up that input file. Well, we know how to do that. We just use the open command, and we have to have a file pointer for this. So I'm going to have an in file and an out file. So let's call this in file is equal to the open. And as usual, I have put my files in the temp folder on the C drive. So I have a double quote C:/temp, and the name of the file is sampledna. And in fact, the name I put for this file, because it's got 1,000 bases in it, is I put 1,000 in there as part of the file name as well. TXT, then we'll close that and follow with a comma. Okay, now recall, if we're opening up a file to read, we don't really have to do anything else. We don't have to put this mode on the end of it. But to show you that it's there, I am going to include the R this time. So that indicates that we are opening a file to read it. That's what the R means. Okay, now let's open our output file. And we do that the same way. We have another file pointer, which I'll call out file, and that's just equal to the open command again. And this time we are going to create a new file. So I'll put it in the same place, C:/temp. And here you get the name of the file. So I'm just going to call this copy dna.txt. Double quote, that closes the name. And we do have to have the mode this time. And since we're creating a file, that mode has to be a W. Then we'll close the parentheses. Now remember that with the W mode, we're going to overwrite any existing file. And I want to do that because I don't want to keep adding on to these files as I run the program several times. Now that the file is open, let's go ahead and read the data into a variable. So I just need a variable called DNA data, and I'm going to use the read function in order to read all the data into that variable. So it's easy. It's an assignment statement. DNA data is equal to infile.read. And then we just have the empty parentheses. So that reads the entire file into that variable. Read all data into variable DNA data. And it's important to remember that. If it doesn't really matter how big your file is, if you use this statement in Python, then it reads that entire file and stores it into this variable that you specify over here. So it's a really big long string in some cases. Now let's print that back to the screen so we can see some output from this, get some response from the program. So we'll just do a print, and we can print out the DNA data variable. So that's all we need to print the data to the screen. Let's count the number of characters that we have as well. So let's do a print, double quote, there are, let's see, double quote there, and let's do a plus, and then we'll print out how many characters that we found. So to do that, we just need the length function, len. So we'll do len, and then the DNA data, DNA underscore data. But you know that that's going to give us an integer value, so we need to convert that to a string. So let's put the string conversion function around that. So that will print out the string there are, and then we'll print out how many characters that there are in the file. And then let's add another string constant over here just to finish our sentence. There are X characters in the file. Okay, period, double quote, right paren. And let me fix the right here. So now we have some output. So with only what we're showing, let's run the program and let's print back to the screen our result, and we'll see how many characters that the program thinks we actually have. Here we go. We have the output. Let's drag it over here. So here is the file. So now if you were to compare the file I showed you earlier, then with this you'll see that we have all those lines. So that's the complete file. And when we did the length command to find out how many characters there were, it counted 1,016 characters. Now, in addition to all of the letters that you see on the screen here in blue, it also counted the end of line characters that show up at the end of each line. So we do get those counted as well as all the characters that we can see. So there we go. We are able to open up the file and print out the data to the screen. Now let's continue to go back to the program and let's do some additional analysis. We want to do just a little bit of work here so that we make some small changes to the file, and then we're going to write the modified data back out to a new file. All right, so let's just count how many occurrences of some of these bases there are. Okay, so let's do count underscore, and let's look for the string CTG. See how many of those we find. So let's do count CTG, and that's just equal to our DNA data, and we want to do a count. So we use the count function, and inside the count function we specify what we're looking for, and what we're looking for is a CTG. Okay, double quote, and then we close the parentheses. So this will give us a count of how many times within this file we see the CTG sequence appear. Now, let's also do a little replacement. So let's create a new DNA file, and let's set that equal to our current DNA data. So there's our DNA data file. And we want to do a replace. And let's replace our CTG with a capital TAG. Now, I'm doing that just so that we can easily see what we have here. So when we replace the CTG with uppercase TAG and print that to the screen, it'll be really easy for us to pick that out. So I'm going to add a line where we are just going to print our new DNA file out to the screen so we can see the changes that we made here. Okay, so we have a new DNA file, and that new DNA file will replace all of the CTG lowercase bases with the uppercase bases TAG. So now, well, let's see what kind of output we get. So I'll bring the output over. Okay, so here is the output to the screen of the original data file. We have the count for that. Then, after we did the replace, you can see that we now have some uppercase bases. You know, TAG shows up in several places, so that is where we did the replace function. And then we printed the modified file back out to the screen. So that's the bottom part here. So now we have modified the file. Now let's write the data out to a file. And we can do that pretty easily. We have this file that we want to write out, our new DNA file. So all we need to do is to just write, put a new line of code here that writes to the file instead of to the screen. So you know how to do that. It's just out file.write. So that's the method that we're using. And then where are the data stored? Well, it's stored in our new DNA file. And then we just close parentheses, and that will output the data to the file. Once we're done, we should always close any files that we have opened. That's just a good programming practice. So let's do infile.close and outfile.close. And then we have terminated the program properly. I'm going to put a comment here that this line is writing the data to a new file. Okay. And the name of that file is this copy DNA that we used up here when we opened up the file for writing. So we have the name specified up there, we have the W mode specified up there. Now let's see what we get. The information that comes to the screen is the same as before. So we have the original data up here, and we have our modified data here with the uppercase TAG, but nothing else has changed. And that's because we wrote data to the file, so we wouldn't expect to see anything new on the screen. Now let's go take a look at the file. So we'll move that out. We'll bring the file browser in. So here is our copy DNA.txt file that we just made. So if I double click, then we'll see what's in there. So here's the new file. And you can see that this file is indeed the new one because we have our uppercase TAG bases that are prominent here. So it's easy to tell that's different than the original file. So we have made a copy of a file. You can do that. You can open as many files as you want in your program. You just have to have a different name for the handle or the file pointer each time. So this little program illustrates how to open file, make a copy, make some changes to the data, and then write the new data out to a new file. Now, the data that I showed you, we had the uppercase there. We had the uppercase TAG, so it was easy for us to spot. But if you want to save this file, then you most likely you don't want to have a mixture of uppercase and lowercase in your bases. So we can make a little modification when we're writing to the file. Outfile write, new DNA.file, and then we could put a dot and we can use the lower method with parentheses. And what that does is it takes any uppercase data that it has here, converts it to lowercase, and then it writes it to the file. So now all the output will be in lowercase. So I will show you the result of that. Okay, so I've run the program, and now we've got the latest version of our copy DNA. So now when I open that up, then you'll see that we don't have any uppercase anymore. Okay, so we have replaced some things here with tag, and now they're really hard to see where we did the replacement. But here's one, there's the TAG and the TAG. So they were uppercase, now they're lowercase. Now your file is consistent, so all 1,000 bases will be in lowercase. So this program or this video then has illustrated the basics for opening up a file for input and then opening up a file for output and then reading in the data and printing the data back out. So we'll close the video at this point.